So let us start with the first concept of this chapter, that is factors and multiples. So what are factors? Factor of a number is an exact divisor of that number. Now you might ask, what is a divisor? Now let us say that we are dividing two numbers. So let us take an example here to understand what is a divisor. Let's say that I have written 4 divided by 2. That means 4 is the number which is being divided by 2. So in this case, 2 is the divisor and 4 is the dividend. So whichever number is being divided, that is dividend, and by which number it is divided, that is divisor. So how do you divide? You divide it something like this. 2 2s are 4. So what do you get? You get 0. So here 2 is the divisor, 4 is the dividend, 2 is the quotient, and 0 is the remainder. So these are the 4 terms that we use when we perform division operation. Now a factor is an exact divisor of a number. Exact divisor would mean that when that number is divided by this number, the remainder will be 0. So that is the meaning of exact divisor. Exact divisor means that the number will be exactly divisible by that number, leaving no remainder behind. So let us look at a few examples. So let's start with the smaller numbers. Let's start with 1. Now, which number is an exact divisor of 1? That means if 1 is the dividend, which is that number which will be a divisor such that the remainder will be 0? So what would be that number? So that number would actually be 1, because 1 into 1 is 1. So therefore 1 is an exact divisor of 1. So we can say 1 is a factor of 1. Now let us consider the next number, that is 2. What about 2? Now for 2, 1 is an exact divisor, because if you divide 2 by 1, like 2 divided by 1 would be something like this. So 1 2s are 2. So the remainder is 0. So 1 is an exact divisor. 2 is also an exact divisor, because if you do 2 divided by 2, what do you get? This is how you do it. So 2 1s are 2. So here also this is an exact divisor. So basically 1 and 2 are factors of 2. And that is why this 2 can be written as 1 into 2. This can also be written as 2 into 1. Right? Because if 1 divides 2 exactly, that means 1 multiplied by something should be equal to 2. And that something is 2. Right? Let's look at the next number, that is 3. So in case of 3, 1 again is an exact divisor. Do you think that 2 would be an exact divisor? No, that's because if you divide 3 by 2, what happens? You see that you get 1 as a remainder. That means 2 is not an exact divisor of 3. So 1 and 3 are the exact divisor of 3. So this can be written as 1 into 3. This can be written as 3 into 1. Now whenever a particular number is an exact divisor or a factor, then that factor will be multiplied with some other number to get this number. Let's talk about 4. 4 is going to be a little different. In case of 4, 1 is a factor because 1 into 4 is 4. Do you think 2 is a factor? Yes, because 2 into 2 is 4. Do you think 3 is a factor? No, 3 is not a factor. What about 4? Is 4 a factor? Yes, because 4 into 1 is 4. So 1, 2 and 4, these are the factors of 4. Let's talk about 5. So in case of 5, 1 is a factor because it can be written as 1 into 5. Is 2 a factor? No. 3? No. 4? No. What about 5? Yes, 5 into 1 is equal to 5. So 5 is also a factor. Let's look at 6. In case of 6, 1 is a factor because 1 into 6 is equal to 6. 2 is also a factor because 2 into 3 is equal to 6. 3 is also a factor because 3 into 2 is equal to 6. What about 4? No, 4 is not a factor. 5 is also not a factor, but 6 is a factor because 6 into 1 is equal to 6. Therefore, 1, 2, 3 and 6 are the factors of 6. So basically, whenever we say factor of a number, that means we are basically talking about the exact divisor of that number. Now, another interesting thing that you will always observe is that the factor of a number will always be either less than the number or equal to the number. It can never be greater than the number. For example, here let's say the number is 6. So what are the factors that we have? 1, 2, 3 and 6. Do you think that you can have any number which is greater than 6 as factor of 6? Do you think that 12 can be a factor of 6? No, it cannot be, because if you divide 6 by 12, what happens? 12 divided by 6. So what do you get? You will get a result in decimals, right? So basically, when we talk about factors of numbers, we are talking about exact divisors. So we are not talking about decimals. We are talking about whole numbers. So they will not get divisible by whole numbers, and therefore bigger numbers cannot be factors. So a factor of a number is always less than or equal to that number. So this is another very, very important concept of factor. Now let us look at factors of some bigger numbers. Let us look at bigger numbers. For example, let's consider 12. Now if I ask you to find the factors of 12. Now 12 is comparatively a bigger number than 1, 2, 3 or 4. So what about 12? Now let's start from 1. Do you think that 1 is a factor of 12? Yes, of course, because if you divide 12 by 1, it will be exactly divisible. So 1 is a factor. 2, yes, 2 is also a factor. 3 is also a factor. Now why 1 is a factor? Because 1 into 12 is 12. Why 2 is a factor? Because 2 into 6 is 12. Why 3 is a factor? Because 3 into 4 is 12. 4, yes, 4 is a factor because 4 into 3 is 12. What about 5? Is 5 a factor? No, because 5 doesn't divide 12 exactly. What about 6? That's true, 6 into 2 is 12, so 6 is also a factor. What about 7? No, 7 is not a factor. 8? No. 9? No. 10? No. What about 11? No. What about 12? Yes, 12 again is a factor because 12 into 1 is 12. So this way we see. Now why didn't we go beyond 12? Because we know that a factor of a number is either equal to or less than that number. So factor of 12 can either be equal to 12 or less than 12. It cannot be greater than 12. So we went only up to 12. So what did we find? We find that 1, 2, 3, 4, 6 and 12 are the factors of the number 12. Let's look at number 13. Now, if you do the same thing for 13, you would see that 1 and 13. These are the only factors of 13. That's because the only possible ways of writing 13 is 1 into 13 or 13 is to 1. So these are the only two factors. Let's now talk about multiples. Now, a number is said to be a multiple of each of its factors. Now, very interesting. Factors and multiples are very closely related. So it is something like this. Let's say that you have a sister. So what will you be to your sister? You will be your sister's brother and she will be a brother's sister and you will be a sister's brother. So how is the relation like? So let's say that the name of your sister is, say, Reena. And let's say that your name is Sunny. So this means that Reena is sister of Sunny and Sunny is brother of Reena. So that's the relation, right? So in a similar way, if you see that, say, 2 is a factor of 12, that would mean that 12 is a multiple of 2. So that is how the relation is. So let's say 2 and 12. So if we say that 2 is a factor of 12, then we will have to say that 12 is a multiple of 2. So a number is always a multiple of each of its factors. So let us understand this with examples. Now we had seen in the previous slide that for any number, let's say for number 3, we have how many factors? It has 2 factors, 1 and 3, right? Why? Because 3 can be written as 1 into 3, it can also be written as 3 into 1. So this means, what does this mean? This means that 3 is a multiple of 1. 3 is also a multiple of 3. So 3 is a multiple of 1, 3 is a multiple of 3. Similarly, if you take number 4, so 4 can be written as 1 into 4, it can be written as 2 into 2, it can also be written as 4 into 1. So it has 3 factors, that is 1, 2 and 4. So that means that 4 is multiple of 1, 2 and 4. Let's talk about 6. So what are the factors that 6 has? So 1 into 6, 2 into 3, 3 into 2, 6 into 1. So 1, 2, 3, 6. These are the factors of 6. So this means that 6 is multiple of 1, 2, 3 and 6. So this is the meaning of multiple. Now let us try writing multiples of different numbers. So let us start with the small numbers. So let's start with 2. So how do we write multiple? How do we write multiples? Multiple means whenever you multiply a number to this number, you would get another number. So that would basically become its multiple. For example, if you multiply 1 to 2, you get 2. That means 2 is a multiple of 2 because 2 can be exactly divided by 2. Similarly, if you write 2 into 2, which is equal to 4, that means 4 is divisible by 2. That means 2 becomes a factor of 4 and 4 becomes a multiple of 2. So please understand this concept very carefully. Now, the exact divisor of any number is called its factor, right? And the number of which it is a factor is called its multiple. So that's the simple concept. So in this case, 2 into 2 is 4. That means 4 is a multiple of 2 and 2 is a factor of 4 because 2 is an exact divisor of 4. Similarly, if you write 2 into 3 equal to 6, that means 6 is exactly divisible by 2. So 2 is a factor of 6 and 6 is a multiple of 2. 2 into 4 is equal to 8, which means 8 is exactly divisible by 2. Therefore, 2 is a factor of 8 and 8 is a multiple of 2. So that's the logic. Now in this way, we can write down all the multiples of 2. And this will continue because as you keep increasing this number 1, 2, 3, 4, 5 and so on, you will continue to get these multiples. So how many multiples exist for 2? Infinite, because this 1, 2, 3, 4, the counting will go till infinity. We know, right, that natural numbers, whole numbers, they continue till infinity. So basically 2 multiplied by infinity will become some infinity. So that means we can say that there exists infinite number of multiples for a particular number. So please understand the concept of or understand the relationship between factor and multiple very, very clearly. So let us take any one example from this. So can you tell me from this who is a factor and who is a multiple and why? So if you take this instant, you will see this means that 8 is exactly divisible by 2. Now since 8 is exactly divisible by 2, that means if you divide 8 by 2, what will you get? You get 4. So that means that 2 is a factor of 8 and it also means that 8 is a multiple of 2. So that is the simple concept of factors and multiples. Right? Let's try to write multiples of the number 3. How would you write multiples of 3? 3 into 1, 3 into 2, 3 into 3, 3 into 4, and so on. So what do you get? 3, 6, 9, 12, and so on. So in this fashion, you can write down the multiples of 3. Now in similar fashion, you can also write multiples of bigger numbers. So let us take an example. Let's consider 12. So how would you write multiples of 12? Just keep on multiplying the various natural numbers like 12 into 1, 12 into 2, 12 into 3, 12 into 4. So what do you get? You get 12, 24, 36, 48, and so on. So this can go till infinity. So there exists infinite multiples of any number. So you talk about even bigger number like 200 or 20. So it would be 20 into 1, which is 20, 20 into 2, which is 40, 20 into 3, which is 60, and so on. So in this way, we can write down multiples of numbers. So I hope that the relationship between factors and multiples is clear now. So now we will look at some categories of number or some types of numbers based on their factors. Now we understood the concept of factors. Now looking at how different numbers have different sets of factors, we will categorize them into different types. So what are these different types? We will talk about prime numbers, we will talk about composite numbers. So let us look at what are prime numbers. The word prime means something which is like important, which is primary. So that those are the places where we use the word prime. Now these are those numbers whose only factors are 1 and the number itself. Now as we have noticed that for every number, if we try to find out their factors, we will see that 1 is always a factor of that number. And we also see that the number itself is also a factor of that number. Now, if we come across a number where the only factors are 1 and the number itself, that is, there are no other factors than these two, then those numbers are called prime numbers. That's interesting, right? So let us look at some examples of prime numbers. Think of 2. So if I ask you to write down the factors for 2, 2 can be written as 1 into 2 and 2 into 1. So basically it has two factors, 1 and 2. So 1 and the number itself. So 2 is a prime number. Similarly, let's consider another number, 23. So 23 can be written as 1 into 23, 23 into 1. You cannot write it in any other way. So that proves that it has only two factors, 1 and the number itself. Think of 5. 5 also has two factors, 1 and 5. And that is why 5 is also a prime number. What about 7? 7 also can be written either as 7 into 1 or 1 into 7, which shows that it has two factors, 1 and itself. So therefore, all of these are examples of prime numbers. So then, what are composite numbers? So composite numbers are exactly those numbers which are not prime. So basically, these are numbers with more than two factors. That means these numbers will have 1 as a factor, the number itself as a factor, plus some other factors. So let's quickly look at some examples. Let us consider 4. What about 4? How many factors it has? 4 can be written as 1 into 4, 2 into 2, 4 into 1. So basically it has 1, 2 and 4 as factors. So 1 and the number itself, plus it has one additional factor, that is 2. Therefore this is a composite number. Think of 6. So 6 can be written as 1 into 6, 2 into 3, 3 into 2, 6 into 1. So basically it has 1, 2, 3, 6 as the factors. So you see, other than 1 and itself, it has two more factors, that is 2 and 3. So now when you look at the series of numbers starting from 1, so what are the numbers that we come across? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Now from 1 to 10, can you tell me which one is prime and which one is composite? Now let us start from 2. We saw that 2 is a prime number. 3 is also a prime number because 3 is divisible only by 1 and 3. 4 is not a prime number, so 4 is a composite number. 5 is again a prime number. 6 is a composite number. 7 is a prime number. 8 is a composite number. What about 9? 9 is a composite number because 9 has multiple factors like 1, 3, 9. So 9 is again a composite number. 10 is again a composite number because 10 has multiple factors like 1, 2, 5, 10 and so on. So in this way we can decide whether a particular number is prime or composite. Now you might ask, what happened to 1? So if 1 is a prime number or a composite number. Now 1 is not a composite number because it doesn't have more than 2 factors. So it is not composite number. Is it a prime number? Because 1 has only 1 factor. So what would be the factor for 1? 1. So 1 and the number itself, but the number itself is also 1. So in this case, therefore we cannot really consider 1 as a prime number as well. So what do we say? 1 is neither prime nor composite. So 1 is like an exception to this concept of prime and composite numbers. So let us look at these numbers on the screen and decide whether it is a prime or a composite number. So let us start with 56. So what are the different ways we can write 56? It can be written as 1 into 56. It can be written as 2 into 28. Do you think it can be divisible by 3? No. It is divisible by 4. 5? No. 6? No. 7? Yes. 7 into 8 is 56. So 8, yes, 8 into 7 is 56. Then 14 into 4 is 56, 28 into 2 is 56 and 56 into 1 is also 56. So considering these, we can say that it has multiple factors. So how many factors it has? 1, 2, 4, 7, 8, 14, 28 and 56. So it has 1 and the number itself. Besides that also it has so many factors. So it has more than 2 factors, therefore it is a composite number. Consider 1. So just now we discussed about 1 and we found that 1 is an exception. So it is neither prime nor composite. Let's consider 23. So what are the different ways you can write 23? 1 into 23 and 23 into 1. It is not divisible by any other number like 2, 3, 4, 5, 6, 7 and so on. So therefore 23 is a prime number. Think of 15. So 15 can be written as 1 into 15. It can also be written as 3 into 5, 5 into 3, 15 into 1. So basically it has more than 2 factors like 1, 3, 5, 15. Therefore this is a composite number. Let's look at the last one, that is 27. 27 also can be written in many different ways like 1 into 27, 3 into 9, 9 into 3, 27 into 1. So this also has multiple factors and therefore it is composite. So in this fashion, by finding out the factors of a number, we can decide whether that number is a prime number or a composite number. So now that we are clear with the concept of prime numbers, we are clear with the concept of factors and common factors and multiples, it is time that we introduce something very interesting concept called prime factorization of a number. So factorization, what is the meaning of factorization? Factorization means writing a number in terms of its factors. So when a number is expressed as a product of its factors, we say that a number has been factorized, or that is called factorization of a number. Basically, writing a number as product of its factors. So let us say, let's take a very common example. Let's talk about the number 8. So 8 can be written as 2 into 4. So 2 is a factor of 8. 4 is also a factor of 8. So we have written 8 as a product of two of its factors. So this means that 8 is factorized, or this is called factorization of 8. 8 is written as product of its factors. Then what is prime factorization? When a number is written as a product of its factors such that all the factors are prime numbers. Now in this case, is this prime factorization of 8? No, because 2 is a prime number, but 4 is not a prime number. 4 is a composite number. So this is not prime factorization, but this is only factorization of 8. So how will we do prime factorization of 8? Now if we write 8 as 2 into 2 into 2, like this also we can write. Now in this case also we have written 8 as a product of its factors. So basically here also we have factorized 8. But now if you see, here all the factors are prime numbers. So we can say that we have prime factorized 8, or this is called prime factorization of 8. So when a number is expressed as a product of its factors such that all the factors are prime numbers, then we call it the prime factorization of that number. So let us take some other examples. Let us talk about a number 54. So 54 can be written as 9 into 6 or 6 into 9. So this is factorization of 54, but this is not prime factorization because neither 6 nor 9 is a prime number. But if the same thing is written as, now 9 can be written as 3 into 3, 6 can be written as 2 into 3. So 54 can be written as 3 into 3 into 2 into 3. So 3 and 2 are also factors of 54. So we have basically written it in the form of factors which are prime numbers. So therefore this is prime factorization of 54. So how exactly do we do prime factorization of a number? So let us say the number is 54. So we start with the smallest prime number. Which is the smallest prime number? It is 2. 2 is the smallest prime number. Now when you divide 54 by 2, what is the quotient that you get? 2 2s are 4, then 2 7s are 14. So 27 is the quotient that you get. So you write the quotient. Now you again divide this by the smallest prime number possible. Possible in the sense which is the smallest prime number by which this will be divisible. So 2 by 2, 27 will not be divisible, but by 3 it will be divisible because 3 9s are 27. Again 9 will be divisible by 3. So 3 3s are 9. Right? Again this 3 will be divisible by 3, that is 3 1s are 3. So you perform this until you get a 1 here. Until and unless you get a 1 here, you continue the process. So once you have done this, then you can write 54 as product of all these factors, that is 2 into 3 into 3 into 3. 2 into 3 into 3 into 3. So this is how we do prime factorization of a number. So you start with the smallest prime number by which that number is exactly divisible. Then you write its quotient and again repeat the process with the smallest prime number possible. And continue this until you get 1. And then you can represent that number as product of the prime factors. So let us look at some examples of prime factorization. So the first example that we will consider is a number 70. Now let us do prime factorization of 70. So which is the smallest prime number by which 70 will be divisible? 2 is the smallest prime number. 70 has 0 in its units place. So 70 is divisible by 2. So what would be the quotient? 2 3s are 6, 2 5s are 10. So it will be 35. Now do you think 35 will be divisible by 2? No, because it doesn't have 0, 2, 4, 6 or 8 in its units place. Will it be divisible by 3? No, because sum of the digits is 8 and 8 is not divisible by 3. So it will be divisible by 5. So 5 7s are 35. Now 7 is a prime number. So 7 will be divisible only by 7. So this will be 1. So you have got 1 here. So how will you prime factorize it? This will be 2 into 5 into 7. So 2, 5, 7, all of them are prime numbers. Let's look at another example. Let's consider a number 450. So this is comparatively a bigger number. So let's start with 2 again. 2 2s are 4, 2 2s are 4, 2 5s are 10. So 225. This will again be divisible by 5 because we know that a number is divisible by 5 whenever it has 0 or 5 in its units place. So this would be 5 4s are 20, 5 5s are 25. Now this will again be divisible by 5, 5 9s are 45. Now this 9 will be divisible by 3, so 3 3s are 9, 3 will be divisible by 1. So 3 1s are 3. So what do we get? We get it as 2 into 5 into 5 into 3 into 3. So we say this is the prime factorization of 450. So now that we have learned about prime factorization and we have also learned about factors, common factors. So now we will learn about highest common factor. Now we saw that two numbers can have a common factor. Now we also saw that two numbers can have multiple factors in common. So which would be the highest common factor? That is what we are going to determine in this section. So highest common factor, which is abbreviated as HCF, is the highest of the common factors of two or more numbers. Now you might be thinking, what is the significance of finding out the highest common factor? So we will get to know the significance once we talk about its applications. So in day-to-day life, we come across many such problems whose solution lies in finding the highest common factor between two or more numbers. So what are those real life examples? We will talk about them slightly little later. So for now, let us first try to understand how do we find highest common factor or HCF. So let us take examples of some numbers. Let us try to find out the highest common factor of 15 and 20. So for that, let us first find out the factors of 15. What are the factors of 15? 1, 3, 5 and 15. Similarly, let us note down the factors of 20, and that would be 1, 2, 4, 5, 10 and 20. Now by now you know how to find factors, right? So you will be able to find the factors of both 15 and 20. Now let us mark the common ones. 1 is a common factor to both of them. 5 is also a common factor to both of them. So what are the common factors? So if we talk only about the common factors are 1 and 5. So which is the highest common factor? That is 5. So 5 is the HCF between 15 and 20. So let us take another example. Let us talk about 24 and 36. So if you have to find out the highest common factor between 24 and 36. Again, let's make a note of all the factors of 24. It would be 1, 2, 3, 4, 6, 8, 12 and 24. Let's make a note of the factors of 36, and this would be 1, 2, 3, 4, 6, 9, 12, 18 and 36. So let us encircle the common factors. So 1 is a common factor, 2 is a common factor, 3 is again a common factor, 4 is a common factor, 6 is also a common factor, and after that you have 12 as a common factor. So you have so many common factors. So if you talk about the common factors, you have 1, 2, 3, 4, 6 and 12. And which is the highest common factor? That is definitely 12. So HCF of 24 and 36 is 12. Now, what is the meaning of HCF basically? It is the highest common factor, or we can say that it is the greatest common divisor. That means it is the greatest value which can divide both of these numbers exactly. So if you divide 24 by 12, you will get 0 remainder. If you divide 36 by 12, you will get a 0 remainder. So that means 12 is a divisor for both 24 and 36, and it is the greatest common divisor. This is the greatest possible number which can divide both 24 and 36 exactly. So that is the exact meaning of highest common factor or HCF, or it is also sometimes called as GCD, that is greatest common divisor, but most commonly it is termed as HCF. Okay, so let me quickly recap. What is HCF? HCF denotes that number which divides two or more numbers exactly, and it is the greatest possible number which can divide two or more than two numbers exactly. For example, in this case, 5 is the greatest possible number which can divide 15 and 20 exactly. 12 is the greatest possible number which can divide 24 and 36 exactly, and that is what is HCF later. So for now, let us try to understand that is there any better way of finding HCF, because we saw that while finding HCF of 24 and 36, you actually need to note down all the factors of 24, then all the factors of 36, then find out the common ones, then decide which is the highest common factor. So that would consume more time. So here we have a method called prime factorization method. So with this prime factorization method, very easily and very systematically, we will be able to find out HCF of two numbers. So let us see, how do we do that? So let us say that you have to find out HCF of 15 and 20. So I am again considering the same numbers just to show that here we are able to find HCF with ease. So how do we do it? So we will do prime factorization of both the numbers. So by now we know how to do prime factorization. The smallest possible prime number is 2. But do you think 2 will divide 15 exactly? No. So which number would divide it exactly? It is 3. So 3 5s are 15 and then 5 1s are 5. So 15 can be written as 3 into 5. Let us perform prime factorization of 20. So 2 into 10, then 2 5s are 10 and then 5 1s are 5. So 20 can be written as 2 into 2 into 5. So you have prime factorized both the numbers. Now looking at these two numbers, do you see something in common? 5 is common, right? So this means that the highest common factor of these two numbers is 5. So it is pretty simple. The logic is also very simple. What we are doing is we are writing those numbers as product of their prime factors. Now we compare their prime factors, and whichever is the common prime factor, that is its highest common factor. Now if you compare this method with the previous method that we discussed in the previous slide, what did we see? So in the previous slide also we saw that these two numbers 15 and 20, they had many other factors also. But out of them, they had two common factors, 1 and 5. So here also it is the same. It is just that we are not writing into 1. Because 1 is multiplicative identity. Multiplying by 1 will not make any difference. So that is why we are not writing 1. But 5 is common, and again we can see that 5 very distinctly. But in this case, the benefit is that you don't really need to find out factors. Because finding factors is time consuming, because you start counting from 1 and then you start finding, okay, which one is a factor and which one is not. Now let's look at the next example, which will actually prove that this method is better. So here we will find out HCF of 24 and 36. So let us do prime factorization of 24. So this would be 12, this would be 2 into 6, 12, this would be 2 3s is 6, and this would be 3 into 1. So 24 can be written as 2 into 2 into 2 into 3. Now let us talk about 36. So here this would be 2 18s are 36, 2 9s are 18, and then 3 3s are 9, and 3 1s are 3. So 36 can be written as 2 into 2 into 3 into 3. Now tell me, what do you see in common? So in this case, this 2 is common, 2 is here, 2 is also here. Do you see anything else common? This 2 is also common because 2 is here and 2 is here. Is this 2 common? Because here you have a 2 but here you do not have a 2. So this is not common. Is this 3 common? Here you have a 3 and here also you have a 3. So these are the common things that we have. So what are the common things that we have? What is that thing which gets repeated in both the cases? It is 2 into 2 into 3. So basically 2 2s are 4, 4 3s are 12. So 12 is a common factor for both 24 and 36. So this prime factorization method helps us to find the HCF in a very, very easy way. So in this way, what we are actually doing is, by encircling them, we are able to find out the common factors. At the same time, what we are doing is we are multiplying the prime common factors. By multiplying the common prime factors, we are able to find out the highest common factor. Right? In this case, 2 is a common factor between 24 and 36. This 2 is also a common factor. 3 is also a common factor. But when we multiply all of them, then what do we get? We get the highest common factor between 24 and 36. And this is the prime factorization method. So whenever you have to find out HCF between two numbers, two or more numbers rather, so make use of prime factorization method because it is simpler and it is also